Okay, so we're at Integrated 2, 4.1.5, factoring special cases. So this is a continuation of the difference of squares that I talked about in the 4.1.4 and with the perfect square trinomial. All right, so if we take a look at the difference of squares, we've got our pattern here. So we're just going to keep doing a little bit more practice with this. So the first thing that we're going to want to do, taking a look at the questions, one, we're still going to follow the same process. We're always going to look for the GCF first. Now, every single thing has a GCF. We just want to make sure that that GCF is not 1. So, because dividing by 1 doesn't do us any good. So if the GCF is 1, then we don't necessarily show factoring it out. So if we take a look at the first question, the GCF is 1. So there's nothing I could do here. The next thing that I would do is actually take a look to see how many terms it is. So following my little roadmap from last time, I have 2 terms this time. All right, let's see. The only thing that we have, if it's not a GCF for 2 terms at this point, would be a difference of squares. So it needs to be a difference. So we got to be subtracting 2 things. Another way to look at it is we want to make sure that one of the terms is positive, whereas the other term is negative. That's another way you can think about it. So difference, check. We've got the subtraction. It's right there in between. So we've got our subtraction of squares. All right, so the next thing we have to do is determine whether or not we could square root each of the terms. Notice that I'm ignoring the subtraction because that's the difference part. So I have to ask myself can I square root each of those? And yes, I can, absolutely. So I'm going to square root the first term. So let's do a little bit of color coding here. If I square root x squared, I'm going to get an x. Well, I'm going to write it down twice. So 2 sets of parentheses here. So 1 set of parentheses I like to put right underneath the question. And the other one, I just tack it right along with it. So the x squared was first, so when I square root it, it goes in first. Just try to keep it a little organized for myself. Then I'm going to take a look at the 49. So ask myself, can I square root the 49? Yes, I can. Notice that it is second, so I'm going to put those in second inside the parentheses. Now the only other thing that I have to do is make sure that I handle the sign. Well, we can't do this if it's an addition problem at all. It has to be subtraction. Or think about the whole, we have to make sure that one of them is positive and the other one is negative. Okay, so now we're thinking about just multiplication to try to get that negative. Well, the only way that'll work is if the signs are opposed to each other, because we know that a negative times a positive is going to give us that negative. And actually, we're done. That is the entire answer to this question. Is x minus 7 times x plus 7. Now, B is along the same line. So all we're going to do here is the difference of squares. So first thing, GCF. No, well, yeah, it's a 1 though. Okay, the next thing I'm going to ask myself is, can I square root? And I think so. That can be square rooted and that can be square rooted. Okay, now we have to check the difference part. So one of the terms needs to be positive and the other term needs to be negative. Ideally, we want it to be the positive and then subtract the next number. All right, so I think we're good. Let's see if we can do this. So we're going to take this first term and we're going to square root it. So square root the 4 is 2. Square root the x squared is x. I'm going to open my parentheses, one right underneath it, and then another one right next to it. And the 2x goes in first in both of them because the 4x squared was first. All right, now let's take a look back. We have a 25. Can I square root that? Yes, I can. The square root of that is 5. 25 came second, so the 5's go in second. Now, the only way for me to get that minus is for the signs to be opposed to each other. So I'm going to have a positive and I'm going to have a negative. And I think that that is the answer. Now with the next question, I still have 2 terms, but I'm going to look and see if there's a GCF first, just like I always would. And I think there is. I think I take 2 out of each of those. So let's divide out of 2. That's going to give me a 4 minus 9x squared. All right, we're just going to look inside now. So ask yourself, could I square root each of them? And is there a subtraction sign between them? Or one is positive and one's negative, which it is. Let's just see if you can actually factor this one. Don't forget to take the GCF with you at the very end. Okay, so I could square root. Square root in the 4 gave me 2's. Those went in first. I could square root the 9x squared. That gave me a 3x. Those went in second. One of them is going to be a plus, one's going to be a minus. And then don't forget to bring that GCF with you. Okay, moving on to the perfect square trinomial. Now, I don't want you to have to worry about memorizing another formula if you don't want to. It really is just a pattern that shows up. And I'll show you what I mean. So you've got those formulas up there. They look a little crazy. So I'll show you how I go through and handle this. I look to see if the following patterns will work. So the first thing I'm going to do is I'm going to take the very beginning term. Now you want to make sure that this is in descending order, so standard form descending order. So the square root of x squared is x, so I'm square rooting. Then I'm going to square root the last term. Square root of the 9 is the 3. Now, it's got to be a positive 9, so you have to have a positive number down there at the end. So let's actually box that whole thing. Got to be a positive number. So that's a 3. Okay, now here's what I'm going to do. So here's the rest of my pattern. I am going to multiply those two square roots together. So that's going to give me a 3x. Then I'm going to double it. So I'm going to times it by 2. So I'll times this by 2. Then the last thing I'm going to do, and I know it's kind of an involved pattern, this is why you don't have to do this. I look back up at the question and I look at the sign on the middle term and I match it. Now I look to see, does the thing I just created by square rooting and doubling and matching the sign, does it match the thing on the inside? Yeah, it does. If it does, we're ready to write the answer. I want you to go back up to the part where we square rooted. So where we have the x and the 3. All I want you to do now is just drag the sign down from the 6x. So that's going to be an x minus 3. We're going to write that x minus 3 inside parentheses and square it. That's the factorization of this. Now, if you're not sure or you got lost by the pattern, that's totally fine. You can always use the boxes and diamonds on this one. So let's take a look at B. It's a bit more complicated, but it's okay. I think we can do this. So take the first one and square root it. So that's 2x. Take the last one. Make sure it's positive. And square root it. That's a 5. All right, let's do the same thing we did before. We're going to take these two guys and we're going to multiply them together. That's going to give me 10x. Then I'm going to double it. So I'm going to take that and I'm going to times it by 2. And then I'm going to ask myself, what was the sign for the middle term? So let's go back and take a look at the sign of the middle term. Well, looks like it's positive. So I'm going to put a positive sign next to this 20x. Now at this point, I'm asking myself, does the value that I just created, that plus 20x, does it match the middle term exactly? If it does, we can go ahead and factor. So we're going to go back up to where the square rooting happened. So the 2x and the 5. Drop that middle sign down. So this is going to give me 2x plus 5 squared. And that's the answer to this one. again, you could do the generic rectangular area model. Okay, now this one, C is kind of a mess, so let's reorganize this thing. We want to put it in descending order, so I'm going to put my negative 9x squared first, my 12x second, and then my negative 4. Okay, GCF, I'm still looking at that. Yeah, I think I'm going to take out a negative 1, so the 9x squared becomes positive. Remember, by doing that, we flip all the signs. All right, let's test out our theory here. Okay, so first one, I'm going to square root the 9x squared. That gives me a 3x. All right, let's go down on the list. Square root, remember this has to be a positive 4, which it is now. It wasn't previously until I took out that negative sign. I'll square root that, that's a 2. Okay, now let's take these two guys together, the 3x and the 2, and we're going to multiply. It gives me 6x. After I multiply, now I'm going to double it. So let's take this and times it by 2. So that's going to give me a 12x. Go back up to the question. In the middle term, it's a negative, and we're going to bring that negative sign with us. Now, is the value that we just created identical to the value in the middle? Yes, it is. All right, let's go back up where I square rooted, so the 3x and the 2. Drop the sign from the middle. That's going to give me a 3x minus 2. Squared, but don't forget the GCF. Remember, back up there, we took out that negative 1. So make sure you put that negative 1 out in front again. And I think that's going to be our answer. So again, perfect square trinomials is just another pattern. If you're having a hard time finding the pattern, which is totally fine, you can actually just do the boxes and the diamonds. It'll work.